Hey everyone, welcome back to my C programming series. In today's video, we are going to learn about function pointers. Now, function pointers are a powerful feature in C that allows functions to be called through pointers, adding flexibility and capability to your code. Now, let's explore what function pointers are, how to declare and use them, and also some practical examples. So, let's get started. First, what is a function pointer? To simply put, a function pointer is a pointer that points to the address of a function, allowing you to call the function indirectly. Now, this can be useful in several cases, such as implementing callback functions, dynamic function calls, or even function arrays, which we'll be seeing how to do later on. Now, just like any other pointer that stores the address of a variable, a function pointer stores the address of a function, that is, where the function has been defined. And using pointers, we can call a function. So, let's see the syntax for declaring a function pointer. Now, a function pointer declaration looks similar to that of a function prototype, but in this case, we will have a pointer, that is a pointer variable, which will actually store the address of my function. So let us have a look at the syntax. First, we will have the return type. Now, this return type will basically specify what will the function that I call return. In this case, I want the function to return an integer value. Then we have the name of the function pointer. Okay, this is where we declare the function pointer. Now, one key point to remember here is that whenever we are declaring the function pointer, we need to make sure it is enclosed inside brackets. Because if we don't enclose it inside brackets, it would look something like this. Int, sa, foo, and this is my function. Now this here has a completely different meaning as to that of a function pointer. Here the meaning of this is we have a function foo that returns an integer pointer. Okay, it returns an integer pointer. Whereas in this case, here this means that foo is a pointer to a function which returns an integer. Now in this case, it means that it is returning an integer pointer, and the second case, it is basically a pointer to a function that returns an integer. So this is a key point to remember when working with function pointers. Now coming to the last part of this declaration is basically the types of arguments that my function will take. In this case, my function will take two arguments, which are both integer types. So now let us see how we can use function pointers with the help of a simple example. So here what I will do is I will define two functions, add and subtract. And both these functions will return an integer value. And they will take in two parameters as inputs, int a, int b, and I'll return the sum of these two numbers. Similarly, I'll define another function subtract, which will take two integer arguments, and this will subtract the numbers and return the value, which will be an integer value. Now let's see how we can call these two functions using function pointers. Now first, I will declare my function pointer. Now based on the prototype of these two functions I have declared, it is pretty obvious that I have to declare a function pointer that will return a type integer. Then I will give my function pointer a name so here I will declare my function pointer and give it a name. So I can give it any name which I like. So let's say I'll call it function ptr, and then I will specify the type of the arguments, the data type of the arguments. So here I have declared a function pointer. Now this function pointer can point to any function which I have declared here. Now remember, the one key point to remember here is that this definition which I have specified here, it should match the signature of the function which I have defined. So what I'm trying to say here is that if my function add takes 3 arguments as input, but my function pointer has specified only 2 parameters or 2 arguments, then this can give me an error. So we need to make sure that a function pointer matches the signature of the function which we are going to call. In simple words, it should match the data type, the return type, okay, and it should match the type of the arguments, type and number of the arguments. That's how I will be able to use function pointers properly. So let's go ahead and see this. So first, I will make my function pointer point to the function add. So it's very simple. Here, I will just tell my function pointer I will assign it the address of the function add. Okay. And what I can do is now I can call this function just by calling this function pointer. So let's see how we can do that. So I will store the result. I will store the result in a variable int result, and then using my function pointer, I will call my function. I will pass two arguments, let's say 5 and 3, which will give me a value of 8. And then I will print this value. Okay, let's go ahead, compile and run this. As you can see, I got the value 8. Now what I can do now is I can take the same function pointer and make it point to another function. So now what I will do is I'll make it point to the subtract function. Okay. So now my function pointer will store the address of the second function, and now I can call this function again. Result2 is equal to function pointer, and I will pass the values, let's say 5 and 3, which will give me 2 as my result, and then I will print this result. Okay, just a second. We made a small mistake here. I have printed the wrong value. So let's just compile and run it again. Yeah. So as you can see, the result of addition is 8 and the result of subtraction is 2. So this is how, using function pointers, I can call functions in my program. Now another interesting thing about function pointers is that it can also be passed as arguments to other functions. Now this is seen in a concept called as callback functions or callback mechanism. Now this is useful when we want to pass a function as a parameter and execute it within another function. So let's see how we can achieve this. Basically, how we can achieve callback mechanism using function pointers. So here what I will do is I will declare a function operate. Now this function operate will perform some operation on two integer values, let's say int x, int y. And along with these two integer values, I will also pass a function pointer, that is a pointer to a function. Now here I will declare my function pointer and the arguments it will take. Okay, and I will return the operation, that is I will return the function which I want to execute. It will execute and give me the value, and it will return that value back to me. Now let's define a function here. So here what we can do is we can define several functions. Okay, let's say add. Let's say we want to add a and add b, these two values, and we'll return a plus b. Let's take subtract 2. I will define a function subtract. This will subtract a and b. And let's take another example of multiply. I'll multiply a and b and I'll return the value. Okay, now let's see how we can implement callback mechanism. So what I will do here is, let's say we want to perform multiplication. So I will say operate, I will call my function operate, and to this function I will first pass my first value, then I'll pass the second value, and then I will pass the name of the function which I want to implement. So in this case, I can implement any of these functions. Multiply mul. Okay. So let's pass the name of the function mul. Okay, that is the address of this function. So now, if I go ahead and run this, the result of multiplication is %d, and here I will print the result. Let's go ahead, compile and run this. As you can see, we got the value 4 5s are 20. Similarly, using this concept, I can implement any function that I want, which I have defined here. We only need to make sure that the signature of the function matches the function pointer. So here I will call the function operate again, and this time instead of multiplying, I will give add. I will pass the address of the function add, and the result of add is %d result 2. And similarly, I can call the subtract function. Result 3, operate. I'll call the subtract function. This will give me a value of 0. The result of subtraction is result 3. Okay, let's go ahead, compile and run this. As you can see, we got 20, 10 and 0. So this is how we can implement callback mechanism using function pointers. And this is one of the most important topics when it comes to working with applications or operating systems. Now, let us see another practical application of function pointers. Now, as we have seen, function pointers have many practical uses. For example, just now we saw what is a callback mechanism. Okay, we can this is also seen a lot in event-driven programming or handling menus and commands dynamically. Another common use case is designing arrays of function pointers, which can be used for building state machines or implementing jump tables for efficient function execution. So let us see how we can implement an array of function pointers. So first what I will do is, I will first define 3 functions, just for example. Let's say void function 1, void function 2 and function 3. Let's define these functions. So these functions will just simply print some value. Then we'll make function 2 call some value. And similarly, we'll make function 3 call some. Okay. These are my 3 functions. And now I will create an array of function pointers. So here, what I will do is, my return type is void. Now I will define my function pointer. Here, since I'm creating an array, so I will use a function array. Okay, I'll use the name function array, and it's not taking any input arguments, so I'll leave it just as it is. And here I will pass the address of my 3 functions. Okay, by giving the name, I can just pass the address of these 3 functions. And now let's call each of these functions. So there are 3 functions, that is 0 to 2. We'll increment the value of I, and then using the function array, I can call each of these functions. So let's go ahead and implement this. So as you can see, I called these 3 functions using a function pointer and a function array. So one important thing to note that is that when using function pointers, we are basically essentially calling a function indirectly. Now this adds a level of abstraction but behaves similar to directly calling a function in terms of performance. The main advantage here is that it provides flexibility as the function being pointed to can be decided during runtime of a program. Now let us see some best practices when working with function pointers. Now it is important to note that when using function pointers, uh, although they are powerful, they come with some pitfalls. One common issue is ensuring that the function pointer is correctly assigned before being called. Because if the pointer or the function pointer is pointing to some null value or to some uh, invalid location or location that doesn't exist, which is called as a null pointer, okay, or uninitialized pointer, this can lead to undefined behavior and crashes in a program. And the second thing to make sure is that we should always check if the function pointer is valid before calling. For instance, we can use a if condition like in this case. Okay, this is some of the best practices to follow when using function pointers. And that wraps up for today's lesson on function pointers in C. We explored what they are, how to declare and use them, and how to pass them as function parameters. And we even saw some practical examples on how we can implement callback mechanisms and how we can use an array of function pointers. Now, this may seem advanced at first, but mastering function pointers opens up new possibilities for writing flexible and more modular code. So, thanks for watching and be sure to like the video and subscribe for more in-depth programming tutorials.